You've tested your DNA and that of your family members, and you've now got the results. And you're wondering about that little xDNA result down at the bottom. What is the xDNA? And really, how does that apply to your genealogy research? If we haven't met before, I'm Lisa, genealogy researcher and author here at Are You My Cousin? And this YouTube channel is designed to help you find your ancestors, grow your family tree, and not get overwhelmed in the process. So if that sounds like your cup of tea, you are in the right place. In this video, you have the opportunity to learn from a DNA expert how to use xDNA as part of your genealogy research. Mary Eberly is the founder, genealogy researcher, and DNA expert at DNA Hunters. She's all about helping you solve family history mysteries through the use of DNA research. Listen in on our recent chat all about using the xDNA in your genealogy research. I know I learned a lot.
I have a pretty short PowerPoint presentation.
Are you ready for it, Mary?
I am.
Oh, okay. There you go. Let me make it a little bit bigger for everybody. There we go. Okay, guys, there it is.
Okay. And so today, as Lisa said, we are going to talk about understanding xDNA. And it's an unusual kind of DNA in that a lot of people don't talk about it. You can't buy a kit in order to test your xDNA exclusively. So I really love sharing this with people because it's an interesting kind of DNA that can help in some situations. Lisa, is my slide advancing? Okay, Lisa?
Yes, sorry.
Oh, is
I
it?
had it muted. I had a cough, so I muted it. Yes, the
Okay, great.
slide looks perfect.
Okay, great. So there are certain situations when xDNA can help. But what you need in order for xDNA to work for you is you need a sufficiently large xDNA match. For autosomal DNA, a lot of times we talk about using a 7 centimorgan cutoff for a segment of DNA. But with xDNA, because it's inherited differently than your autosomal DNA, then it's oftentimes recommended that you have a larger segment, so maybe 10 to 15 centimorgans, before you consider it to be a real xDNA matching segment. Another thing to think about is, what if you only have somebody that matches you on xDNA and not autosomal DNA? In that instance, it could be that the match is so far back in time that it's going to be impossible to find your common ancestors. So some people only look at xDNA matches who also match on the autosomal DNA. And I would say for my work, and I do a lot of client work, a lot of unknown parentage work, I will bring in segments that are 7 or more, and even times where there's no autosomal DNA matching, just because I want to see everything, and then I can make a judgment, later to decide, is this real? So the inheritance pattern of xDNA is different than any other DNA we have. This xDNA is one of the sex chromosomes. If you're talking about your 23 pairs of chromosomes, this is your 23rd. So on your 23rd, if you're a woman, which is shown on the left, you'll have 2 X's, one from your father and one from your mother. If you're a man, you will have an X chromosome from your mother along with a Y from your father. So this is not like mitochondrial DNA, it's not like Y DNA, it's not like autosomal DNA. This is unique. And it's really important to understand this pattern of inheritance. And I'll show you why in just a minute. But because of this inheritance pattern, we have a rule when you're thinking about where did this xDNA come from. And that rule is that xDNA never passes through two men. So it's not going to go from your grandfather to your father. It's not going to go from a father to a son. And that's just because men pass their Y DNA to their sons instead of their X's. So you can see that here where the Y goes down to the son. The son also has an X, but that comes from his mom. If you plot that inheritance pattern onto a pedigree chart, you can see that there are only certain ancestors that you can inherit your X DNA from. So this pedigree chart is for a man, and all of his X is coming from his mother. Because she's a female, she's going to get some X from her father and also from her mother. But then when you go back one more generation, this great-grandfather is not going to be a source of that X DNA, because this person, the great-grandfather, will have passed his Y DNA instead to his son. So this is really interesting because it means that if you step back a minute, it means that if a man has an X DNA match, it's going to be on his mother's side. And that's, solely because of this inheritance pattern. Plotting the same thing for a woman, you can see that there are a lot more branches from which she can inherit her X DNA. But there still are certain branches, these ones that aren't pink or blue, including this one, where the X DNA cannot be inherited from. So that means 3 out of the 4 grandparents can be a source of her X DNA, and then 1, 2, 3, 4, 5 out of the 8 great-grandparents, and so on. So this is interesting also, because if you are a female and you have an X DNA match, you know that, for example, it's not from your father's part of the tree. It could be from your father's mother's part of the tree, the colored part, or from your mother's and your mother's father or your mother's mother. But you can see that we do have some dropouts even there. XDNA can be used to help determine the branch that a match is on. So if you've got this XDNA match, you will know that it must come from one of these branches through which XDNA is inherited. You should keep in mind, however, that the absence of an XDNA match isn't dispositive, meaning just because you lack an XDNA match doesn't mean that it wasn't one of these colored in branches. It's just that by chance you did not inherit it along one of these colored branches. So it's kind of like saying, if, let's just say, chromosome 2 had this special ability also, you might match DNA with somebody on chromosomes 1, 3, 7, 9, and then you might think, well, why didn't I get anything on chromosome 2? Well, it's just by chance that the DNA was inherited in those other places. And the same thing for XDNA. It might be possible to inherit it, but you're not necessarily going to. If I plot that colored pedigree chart onto my own pedigree chart, and here I've just blacked out my ancestors from whom I cannot inherit XDNA. And I've left in the names of people that I can inherit my XDNA. And what's interesting from a genealogical point of view is that I have two family mysteries where on this first one, Gustav Seaman, he's listed on all of Rosalie's vital records, but he married Rosalie's mother, who's also Rosalie, when she was 3 years old. So this person was 3 when Gustav married her mother. So the question I've always had is, well, is he the biological father of Rosalie? And I might be able to use xDNA to answer that question. And down here, I have a second mystery, and that is a second great grandmother on my mom's side, and she was an adoptee. So the question obviously was, who were her biological parents? And once again, this is a line that I might be able to use xDNA on. And in this case, that xDNA, since this is a female, could come from her biological father or her biological mother. I want to cover where you can find your xDNA matches, because like I said, there's no xDNA test that's offered by any company. But if you test at Ancestry, and that's an autosomal DNA test, they don't tell you that they're looking at your X, but they are. And if you take those DNA raw data from Ancestry and transfer them to GEDmatch or Family Tree DNA, you will see those X matches. So the data is there. They're not displaying it. They don't tell you what chromosomes you're matching people on in the first place. They're also not including it in the total amount of shared DNA, but it's there. And when you transfer that data into GEDmatch or Family Tree, you'll see it.
So, Mary, can I ask you a question about that?
Oh, sure.
Do you think Ancestry would eventually show that? Because it obviously has benefit to the researcher.
Right.
Or do you have any sense on what that is? But it sounds like the only option at this point, if we want to really include the xDNA portion of it or data, we have to export out to another site.
Right. They have said, every time they talk about it, they have said, we are not going to show you your segment data where you're matching people. They recently did the ethnicity estimates on your chromosomes.
Mm-hmm.
So I don't know if that is like a little first baby step to seeing your segment data with your matches.
Mm-hmm.
A lot of people hope it is, and I guess I hope so too. But so far, yeah, they have not. They have spoken out against doing that.
Okay.
So I actually took my raw autosomal DNA information from Ancestry and I uploaded to Family Tree DNA.
Mm-hmm.
I could have tested there too. You would still get this xDNA information. And this on the top shows 2 different matches. So the blue match and then the red match on my X chromosome. So this is interesting that I the information underlying Family Tree's ability to show me this is from that data that came from Ancestry.
Mm-hmm.
And Family Tree, if you order their autosomal test, it's called the Family Finder test. And if you're going to be transferring, I highly recommend paying them the $19 fee, because that unlocks all the features as if you have tested there. So I'm sorry.
That's a good deal. Yeah, definitely.
Mm-hmm. It really is. So here is 23andMe, and I tested there. They don't allow transfers. And this shows I compared myself to 5 different matches, one on each line, and I shared xDNA with the top one and then the fourth one.
Mm-hmm.
And you can see, here it's obviously a lot more, and here it's just this one segment. So this is nice. GenMatch is another place. So if you transfer results from any of the other testing companies into GenMatch, when you do a one-to-many comparison, you'll get a table like this that's got your matches. And then over here, there's a column for X, and you can click on it to sort either your lowest to your highest or your highest to your lowest. And it looks like I didn't sort it because these aren't in order, but they're popping up at the top because they are my top matches. But I can click on that and then sort. So that is a really nice way to look at it also. GenMatch has many tools for exploring your xDNA. They have a chromosome browser, they have a matrix. So it's got some really nice tools at GenMatch. Okay, so back to that question. How can it help with your research? And I think that really comes down to, you wondering, is there or could there be an xDNA match for this situation? And I have worked for male adoptees who are looking for both of their parents. And when you just have autosomal DNA matches, you can figure out, well, this is parent 1, but you're not sure, is it the father or the mother?
Mm-hmm.
Or you can, that is more of a situation where you have a group of brothers or a group of sisters, or you're looking at a family and you're scratching your head thinking, now is the dad in this group of siblings or is the mom in the group of siblings? And but if you have that person transfer over to Family Tree or GenMatch or test at 23andMe, well, now all of a sudden you're going to have some xDNA matches.
Mm-hmm.
And hopefully from that you can figure out which side of the family these matches are on.
Mm-hmm.
And also, if the male adoptee is just looking for his mother, then any of his X matches are going to be from his mother's side. I also have a female adoptee, and we found her biological father several years ago, but his mother, we've got a name, but she is a recent immigrant, and it's been really hard to find matches that can be attributed to her.
Mm.
So we have a half niece that shares xDNA with her, and that half niece shares a really nice amount of xDNA. And that means that if there are any shared matches with that niece and it's on the X chromosome, then I know that those are people that I can research to see if I can find out more information about this biological father's mother.
Mm-hmm.
So that's another example. So if you're not somebody looking for so recent, like your parent or your grandparent, I go back to my 2 mysteries. And that first one was whether Gustav was my biological second great grandfather. And in that case, I haven't used xDNA to look at that. I've got some matches that I think on the autosomal DNA, I think are from her biological father. But I just haven't been fortunate enough to have them also matching on the X.
Mm.
So that's a case where there could be an X DNA match, but there's not.
Oh, that's too bad.
Yeah, I know after putting this together, I thought, oh, I should really go back and do some data mining to look for X DNA matches and see if I can pull out anything from those X matches.
Mm-hmm.
And the other mystery, though, who are the biological parents? Who are my third great grandparents? So that's where my second great grandmother was adopted as a baby. On that one, I actually did use XDNA to figure that out. So I have actually a whole presentation on that.
Ooh.
And I'll give you a little insight. Let's see. This is my XDNA matches. I painted them through the chromosome map on DNA Painter. And I put my paternal X matches here. And I put my maternal ones here.
Mm-hmm.
And normally you don't paint your brothers, but in this case, I painted my brothers because I knew that those segments that I share with my two brothers are from my mom.
Mm-hmm.
So I think the two different kind of beigey colors are my brothers. This is another match. And then this match was somebody over on GEDmatch. And my one brother is on GEDmatch. And I noticed that he shared XDNA with my brother. So that told me, oh, he's on my mom's side, this
Mm-hmm.
guy with the red segment. And when I looked at his tree, he was all Norwegian.
Mm.
And I was able to go back and find his third great grandfather. And that is my missing third great grandfather.
Oh, wow.
So that it's kind of like a fishing hook, or like where you're, or a
Mm-hmm.
magnet or something, where you can pull this one match out of everybody that I match at GEDmatch and that my
Mm-hmm.
brother matches. And that XDNA was the fishing hook that pulled him out for me to look at. And luckily he had a beautiful tree. Luckily he was Norwegian, and that's my second great grandmother who was adopted is Norwegian. So like all of the evidence came together, and he is biologically related to me through that third great grandfather. And I was amazed that I solved that mystery through XDNA.
That's really fascinating. Yeah, I'm so excited. I'm like, okay, now I need to go look at my XDNAs.
Yeah, and it's just fun. Like you can just print out your pedigree and then like maybe cross off the people that you can't inherit your XDNA
Mm-hmm.
from. And now you've got that like map or that key where this, these are the branches that the XDNA can flow through. So,
Yes.
once you find the X match, you're like, well, you're not looking at your entire pedigree thinking, oh, how am I going to figure this out? You at least have reduced the numbers.
Yeah, the trees that you showed at the beginning about who you can get the XDNA from was huge. That was really a great visualization for me, and I'm sure for the viewers as well, to really be able to. I mean, you just kind of eliminate who you don't need to look at, and sometimes that's a big piece of the puzzle: is who do you not need to look at before you look at.
Right. Yeah, and I have that as a PDF, and I haven't set up a separate link for downloading that,
Mm-hmm.
but I was thinking that if people are already on my mailing list, I will send that out with to my entire mailing list.
Mm-hmm.
So if you're not on my mailing list and you'd like to get that, then just go to my website, sign up. There's a pop-up that comes up, sign up for the newsletter, and then I'll send that out this week. That PDF with the two, for males and for females.
Mm-hmm. Yeah.
So in conclusion, it's this xDNA information is included with autosomal DNA test. It's really important to understand how it's inherited, and it can be useful in the right situation. And I did want to add, I think I forgot to talk about MyHeritage.
Mm-hmm.
What's interesting there is that they test it, but they don't show it in their chromosome browser. So they show you chromosomes 1 through 22,
Mm-hmm.
but they don't show 23, which is the X. And I've actually talked to Daniel about this, and he just basically said, well, we don't do it, and we don't have any plans to do it.
Mm-hmm.
So I thought that was really interesting. That
maybe if enough of us ask for it.
Yeah. Yes, please ask
because
for it.
MyHeritage is very responsive to what people are looking for. So yeah.
Mm-hmm. And when I kind of like threw this question around with some other DNA people, like, well, why do you think that would be? Like they are testing for it, and but they're not showing us. And they said, it is confusing, right? It's this weird kind of DNA. Everybody has it. We as females have 2 copies, men have 1 copy, and it's like once you study it, it's pretty simple about like it doesn't pass through 2 males.
Mm-hmm.
Okay, that's if you know that, then you can color in your own pedigree. Right. But maybe just they didn't want the headaches for people calling and saying, hey, what's wrong? I don't have any xDNA matches, or I don't know.
Yeah, but and maybe it'll be something. It's not something we hear a lot of, or when people talk when the people are talking about DNA matches and stuff. And of course, if the big databases are not showing it to us, then it does kind of fall. The conversation doesn't necessarily take place as much as it could. Welcome back. I hope you found that as helpful as I did when it comes to using my DNA in the genealogy research. If you'd like to see more of Mary and upcoming videos here on this YouTube channel, be sure and hit the subscribe button so you'll be notified when they occur.